All right, so now we're ready to state the binomial theorem. So here's the result. We say let p greater than or equal to 1 be an integer. So it's got to be a positive integer greater than or equal to 1. Here we're talking about raising x plus p, the binomial, x plus y, sorry, the binomial to the p power. Or again, remember, p is a positive integer greater than or equal to 1. And it turns out this will actually be the sum as k goes from 0 to p. P choose k, the binomial coefficient, which oftentimes I'll refer to as p choose k, times x to the k, y to the p minus k. And think about this way. If you were doing this 3 times, okay, we were doing this problem 3 times, and we wanted to get our first power, which would have been on our sum here, if we're going from k equals 0, that would have been x to the 0. So that means I'd have to choose no x's at all. So I would actually be doing 3 choose 0, which would be 1, or you could ask yourself a question, how many ways could you select y from every one of those terms? There's 3 ways to do it. I'm sorry, there's 1 way to do it. What did I say? 3 ways? Sorry. There's 1 way to do it, right? You got to pick all the y's. All right, so 3 choose 0 is 1. All right, so then you'd have your y cubed term. Okay, then we would do k equals 1. And what I would want for k equals 1 is I would want x to the first, y to the second. So I would want an xy squared. So again, going back to that x plus y. All right, I would have to say, okay, to get an xy squared term, how many ways could that happen? Well, I'd have to pick one x out of the 3. I could either pick that x, or that x, or that x. So that could be done 3 different ways. That's why the coefficient 3 choose 1 is 3. And the next one, you'd want the term x squared y. So you'd have to pick 2 of the 3 x's. Well, you can approach the question of 2 of the 3 x's by asking yourself, how many ways could you not get the x? In other words, just pick one y. One of them to be a y. Then the other 2 would have to be an x. That would happen if 3 choose 2 ways. It turns out the binomial coefficients here, when they're applied with an integer, as we've been doing so far, they actually tell you the number of ways to get that many things. So for example, if I look in the 6th row, in the 3rd diagonal, remember the first diagonal is the 0 diagonal. So the 0 diagonal, so if I did 6th row in 3rd diagonal, that would be right here, 3rd diagonal. 6th row, 3rd diagonal is 20. That means if I had a group of 6 things, and I wanted to pick 3 of them, I wanted to pick subgroups of 3, you could actually form 20 different subgroups from 6 things into 3. So that's what the binomial coefficients actually count. And that's why we use them as their coefficient. We can just do the sum as k equals 0 to p. And we can stop there because we don't need to go any further, because if k is bigger than p, right, as we saw with our 5 choose 6 example, right, that's going to bring in 0 to the top to make the whole thing 0. So anything above p isn't going to matter. And of course, k has to be, as we defined, right, k has to be greater than or equal to 1 for that formula, or 0, in which case we know that that sum is 1. So that's the binomial theorem. Let's actually use it to expand a particular binomial. Let's actually use it to expand a particular binomial. So for example, let's do x plus 1 raised to the 5th power. So using a formula, k equals 0. That would be 5 choose 0. 5 choose 0. X to the 0, 1 to the 5th. So that would actually just be 5 choose 0, x to the 0, 1 to the 5th. Plus, k equals 1. 5 choose 1, x to the 1st, 1 to the 4th. Okay, next term would be 5 choose 2. Be x squared times 1 cubed plus 5 choose 3, x cubed times 1 squared plus 5 choose 4, x to the 4th times 1 to the first, plus finally 5 choose 5 times x to the 5th and 1 to the 0 power. Now, instead of computing all these, we can just go up to our 5th row and read off those coefficients there, because those are the binomial coefficients for 5. 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, and 5 choose 1. And so using that, we get our result that x plus 1 to the 5th is 1 plus 5x plus 10x squared plus 10x cubed plus 5x to the 4th plus x to the 5th. Okay. And so we can use the binomial theorem as a way to very quickly expand binomial. And one of the really cool ways to use this is to actually use it as a way to raise your complex numbers to powers. The binomial theorem becomes a really nice way to raise your complex numbers to powers. Okay, so that's the binomial theorem.